It is time for this week's sponsor interview now with Carsten Willems, the co-founder and chief executive of VMRay. VMRay makes a sandbox-based malware analyzer, and they also offer file scoring, sort of more a detection thing at scale, based on the automated dynamic analysis they offer. It's all hinges on their sandbox. So yeah, if you're an incident responder or someone else, and you want to be able to throw suspect files at a verbose sandbox, then go have a look at VMRay. So yeah, back at DEF CON this year, VMRay helped out a bit with a machine learning malware classifier evasion competition that was mostly put together by Zoltan Balas of testing firm MRG Effitas and Hiram Anderson of Endgame Systems. And the idea was to pit contestants against some machine learning based classifiers. They were given some malware samples that they'd have to modify. And at the end, the malware would have to bypass these classifiers before wind up being executed in the VMRay sandbox to show that yes, it's still malware and yes, it's still functional bad software. And the point of the exercise was to demonstrate something that we mostly know already, which is machine learning is a useful tool, but there are pitfalls. Here's Carsten Willems.
The whole ML contest was mainly organized by Hiram from Endgame and Zoltan from MRG Effitas. And Zoltan came to me and said, well, Carsten, we want to build this great competition because everybody's claiming that ML solves everything and AI solves everything. And of course, we all know that is bullshit. Machine learning definitely is a very, very powerful mechanism for a few use cases. And I think malware classification and anomaly detection and that scenario makes sense to use ML. But of course, it's not the silver bullet that will replace everything else. And we have seen AV vendors in the past, which very aggressive and very offensive marketing that wanted to push that AI solves everything. So this contest was pretty interesting. So I don't know how much you have heard about that and how it actually worked. So if you had registered for that contest, and I think it's still running, already it was already solved. So all the challenges had been solved already, and there was a prize that was given out, but the contest will still run until end of October. So if you're interested in breaking ML-based malware detection, take a look at the website, take a look at the link, and you still can participate. So how does it work? You can download 50 malware samples, and you can also download 3 different machine learning based malware detection engines. And in the initial state, all the malware is detected by all of these engines. And now
it's all it's just pure static file analysis, right?
I don't know. It's an ML-based model. It's 3 different models that don't check any signatures, but they extract the features from the file, and in that sense, you're right. It's all static. It's all static features. So there's no sandboxing or anything like this involved in the first place. Yeah. So they extract features from the file content, and in the initial state, all the malware files are detected by all of these 3 models. And these 3 models, 2 of them are more or less academic models, and the other one is an open source machine learning based malware detection algorithm. So the participant, the attacker, can download the models, can download the algorithms, can download the malware samples, and now your challenge is to modify the malware samples that they still remain functional, but that they are no longer detected by the machine learning based algorithms. And as expected, we have seen that it's in most cases pretty simple to achieve that goal. In some cases, it's a bit more complicated, but we saw a lot of participants that were at least able to tweak the majority of the malware samples so that they get no longer detected by these engines.
We did see a paper a little while ago, it was this year, where someone just appended what I would call happy strings to the end of malware samples and managed to slide it by silence. I think they've tweaked things a bit to get that, to solve that particular problem. But that's the thing, isn't it, right? Like, you never quite know why a machine learning classifier is making the decisions that it is making, right? So quite often bypassing these things is just a matter of doing something kind of unexpected and seeing what happens. Was that the approach that most of the contestants took with this?
Yes and no. So one of the down, as you just said it, one of the downsides of all these ML based classifiers is that there is no, or very often, especially in the scenario of neural networks, you don't know why the algorithm decides in a certain way. Yeah, you train it and you train it and you train it and it works in the end, but there is no knowledge, there is no insight that a human can defer from that.
Yeah, someone might ask, how does this work? And you're like, I don't know. I have no idea.
I don't know. But as you said, that blog post or that attack on silence, wasn't it just a string from a popular game that needs to be added?
Yeah,
to
I
the
think so. And it's like games are funny, right? Like game software, it's some of the, that's the stuff that I think those machine learning classifiers have a big problem with, right? Because quite often there's anti-cheat in there, and there's like there's just a bunch of funny stuff in games that make them look a little bit like malware to machine learning classifiers. So I think really what you're doing is they might lower the thresholds a little bit for stuff that looks like gaming software. So you make it look like gaming software, and then it goes, yeah, no worries, right? So I think that is, that gaming software is like kind of like one of those edge cases that these machine learning based classifiers have trouble with, right?
Yeah, I agree with that. So what we have seen by the submissions of the participants on this contest, there were mainly three different approaches to evade the ML based engines. So one approach was pretty simple, just adding some random bytes, some random stuff to the files so that their content changes, and this is called overlaying. So you search for some zero spaces in the file, or some at the end of the file, and you just put some content there, and you tweak it, and you do it in a more or less brute force fashion until the ML engine does not detect it anymore. But the second approach is more interesting because
hang on. I just want to pick that up there, right? Because that's interesting. Because theoretically, like that shouldn't work, right? Unless the content that you're sort of fuzz stuffing into these spaces for it kind of gets misclassified as a feature by the machine learning classifier, right? Like that's the only way that that's going to work.
Yeah, but that brings us back to the point we had earlier. So we don't really know how the ML algorithm internally weights. I mean, we know how it generates and extracts features. We know how it combines them, but in the end, there is some training derived weights that come out of the algorithm in the end, and you don't have any control how that works on data you have never seen before, right? You only know it's for the training set, and that's a problem. I mean, not all of these engines and not all of the files were able to be tweaked in that manner, but the second approach is very much related to that. So with the second approach, you do not just add random stuff, but you add benign stuff. Yeah. So what people did is they extracted code, they extracted whole file sections, whole code sections from existing Windows system libraries and added this benign code at the end of the file. Yeah. So there were much more benign features.
Yeah, so this is kind of what I was getting at with that last thing where I sort of interjected, is that, stuffing random stuff into a file, like how is that going to trick something that is supposedly extracting features, right? Whereas taking like known good strings and just sort of stuffing them into a file, I can definitely see how that might bear some fruit.
I don't know exactly how these ML algorithms work, because I was doing fundraising for the last 10 months, so I was not that much involved in the technical details of that contest. But in my academic life, 6-7 years ago, I spent a lot of time in building or in combining machine learning with dynamic malware behavior data. And what we saw all the time was it's not that much about the cleverness of the machine learning algorithm, but it's mostly about the quality of the data that you use for training, that you use for feature extraction and all that stuff. So therefore, if you have the wrong features, if you just take some random bytes, I don't know how they actually, if they did histograms or n-grams or whatever, how they extracted features from the files. But if the feature quality, if the feature selection process is not well done, then you can put the smartest ML algorithm, the hardcore powered machines.
It's only as good as its training,
yeah.
right? Like, yeah, no, I get it.
Exactly, and that is what we see oftentimes when people, we use AI, we use ML. They don't know that much about ML, right? They just use some libraries, and they may be using the right or the wrong algorithms, but as they do not really understand what is the essence of a totally unsupervised automatic classification process, it will never solve a problem. But you can put the AI and ML included sticker on your product, and that's
as long as it's on the website, that's fine. So what was the third way that people were doing this?
That was using packers. Yeah. So one problem with traditional antivirus detection that is based on signatures is that once you change a few bytes or once you use a packer, the whole structure, the whole hash value, everything changes. And that is the reason why so many, or why every single antivirus product, traditional antivirus product in the world comes with some automatic unpackers. Yeah? So every time an AV engine tries to find out if a file is malicious or not, they try to unpack it so they can apply their signatures. And this is not done, at least not done by these ML algorithms that we used in the contest. So by packing the file, it was pretty easy to destroy all the features, to generate a lot of noise, and then it didn't work anymore. One problem with that is that, I didn't mention one point here in this contest, because it was not sufficient only that your malware gets no longer detected, but the other requirement that was that your malware was still completely functional, of course, right?
Yeah.
And a lot of these packers, if they were not applied properly, they destroyed some of the capabilities, some of the functionality of the malware.
Well, we should point out too, VMRay's role in this whole thing is after these samples were slid by, they went into your sandbox to get blown up and make sure that they still did all of the bad things that they were supposed to do, right?
Yeah. So our role was let me go one step back. The one of the drivers of inventing the whole sandboxing concept in one decade ago was that a sandbox is totally immune or agnostic to a packed malware, to an encrypted malware. We don't care. We as a sandbox vendor, we don't care if something is obfuscated, encrypted, how many protection layers.
That's the whole point of dynamic analysis, right? Like, that's the point.
Exactly.
Yeah.
Exactly.
You're looking at what it's doing, not what it looks like it's going to do.
Exactly. And therefore, VMRay was used as an evaluator or an assessor or an oracle. We just executed all the malware files we got. We generated a report, and by comparing the report of the unmodified malware to a report of the tweaked malware, it was super easy to automatically and in a scripted way find out if the malware is still functional. Yeah, and that was the role of VMRay.
So look, it sounds like in the case of this competition, you had your 3 machine learning based classifiers. We should be careful too to point out that these were not necessarily fully developed production ready machine learning algorithms used by the likes of all these AV companies that are using that, and they are doing other stuff besides just doing static classification, right? This is a cut down exercise, right? Yeah. So just got to say that. But it sounds like, it's a good starting point, right, for this sort of adversarial trickery. End result was you would have had a lot of people successfully sliding by.
Yeah, and as we've seen from other real world practices, the actual way to kill or to evade a commercial product that uses ML or that relies on ML is not that much different. Yeah, it's probably more tricky and more work involved and so on the forest. But the general, the general principle is the same. And we all know that these ML detection engines, while on the one hand generating more false positive, on the other hand, they can be evaded like any other security.
And then it becomes the same game, right? Which is like what the signature-based companies were doing, which is trying to get it, instead of trying to create a signature, you're trying to get it into your training set quickly so that it's detected, right? And we're sort of back at square one. That's really interesting. I'm going to drop a link into this week's show notes so that people can go have a look at the competition. As you point out, it's still running, so if they want to go have a play with that, they can. But the other topic that I just wanted to very quickly touch on, you've just raised, as you mentioned, you've been doing fundraising the last 10 months. You've just raised a buttload of money, which is great, $10 million. What are you going to do with it?
We have a pretty great technology, and as of today, we are at a point where we really need to scale up our sales organization, our whole operation organization, so more people can benefit from our great.
And is that going to be both on the sort of malware analysis side for people who are taking funny samples and throwing them in? I mean, that's your primary sort of use case, but you do a bunch of deals with vendors too, as like for file scoring and stuff at scale. Are you going to be just pushing forward and trying to build both of those sides of the business?
So we started as a pure malware analyzer so that very skilled people can use our solutions to analyze unknown stuff, very, very sophisticated stuff where other solutions fail. And of course, the analysis of an unknown file is a necessary and required step to detect zero-day malware. Yeah, without a proper analysis, you are not able to detect something. I mean, yes, you can use machine learning with all the ups and downs that we addressed earlier.
But look, I get it. Your involvement in this thing, it's to prove a point, right? Which is at the end of the day, ultimately, some sort of dynamic analysis, there's always going to be a place for that.
Exactly. But having this said, as we can detect zero-day malware with this analyzer, and we can do that at scale and with a very, very high detection efficacy, more and more of our existing customers said, well, please give us a solution that we can not only use after something bad happened, but give us a solution that we can integrate into our email gateway, that we can integrate in our proxy, that we can integrate through an API in whatever way and in whatever product we like. And we just want to detect something. We don't care that much about why you think something is malicious, but we have seen that.
I get it, Carsten. Ultimately, VMRay is a sandbox company, and whatever applied use you can spin off, you're going to do it.
Exactly. And unfortunately, the big grow opportunity for us lies in the detection market and not in the analysis market, because the analysis market.
Why do you think I asked, Carsten? Because that's it, right? Like, I mean, you've just got a much bigger market there, right? Because detection is huge, and I have a feeling personally that the detection market is going to become more collaborative in the future. I had an interview with a blockchain startup, believe it or not, some time ago, and their whole idea was to build an incentive model so that people could submit samples and they would go and get scanned by different engines. And
you're talking about Polyswarm, right?
Yeah, Polyswarm, man. Like, that's interesting stuff. Yeah. So, and I think that's where it's going to go, and that puts you in the box seat. We've already gone massively over time, Carsten, so I'm going to wrap it up there. But congratulations on your Series B. As I say, I'll drop some links into the show notes so people can check out that competition. And as always, a real pleasure to chat to you.
Thanks a lot for having me on the show. That was awesome, like every time. Thank you, Patrick.
That was Carsten Willems of VMRay there. And I always really enjoy talking to Carsten. You can probably tell. You can check them out at vmray.com. And I have seen VMRay in action, and it is a really effective tool for getting a quick idea on what a file actually does when it's executed. So you can get VMRay as a cloud service too. So if you are looking for a sandbox-based analyzer for those files that, VirusTotal and other tools just don't have ready answers for, then do check them out at vmray.com. And that is it for this week's show. I do hope you've enjoyed it. I'll be back tomorrow with a Soapbox edition featuring Yubico. There won't be any weekly news shows for a couple of weeks, as you heard earlier. But until next time, I've been Patrick Gray. Thanks for listening.